Hey there! Today we have an intriguing problem to dive into. The issue at hand revolves around an interesting speed disparity observed in a benchmark test involving a constexpr Fibonacci function. The scenario unfolds as follows. We start with a generic Fibonacci function, and when benchmarked, we notice a significant boost in performance when the function parameter is changed in sign and const in number. Quite a puzzling development, isn't it? Now, let's delve into the solution that sheds light on this perplexing problem. The key lies in the intricate details of the provided code snippet. We have a trio of Fibonacci functions, Fibo_CBB, and Fibo_CBR, each with its own approach to computing the Fibonacci sequence. The crucial difference surfaces in the implementation of Fibo_CBR, where a smart algorithmic twist optimizes the recursive calls by employing tail recursion and utilizing lookup tables for specific values of n. This innovative strategy leads to a dramatic enhancement in performance, proving that the seemingly simple change from call by value to call by reference isn't the primary driver of the speed boost. To sum it up, we've uncovered a fascinating optimization tale hidden within the realm of Fibonacci computation. The intricate dance of compilers, recursion, and algorithmic optimizations has revealed a clever solution to a seemingly straightforward problem. With that, it's time to wrap up our exploration. I hope you found this journey through Fibonacci functions and compiler magic both enlightening and entertaining. Don't forget to subscribe, like the video, and drop a comment below. Until next time, happy coding and may your algorithms always run swiftly and smoothly.